Hello and good morning. Let's take a look at today's bell work. First of all, remember, do not turn in bell work until the end. If you turn it in with your homework, you will lose points, okay? Because I don't want it till the end, okay? Anyway, today is week 3-2, and today is 11-2, so it's Monday, Tuesday, and today is Wednesday. Let's take a look. What does 250, 550 insurance mean? Well, this is your bodily injury. Okay, so it's 250,000 per person. Okay, so if a person has medical bills up to 250,000, your insurance will cover it. If it's 300,000, they will not. You're going to have to come up with $50,000. So make sure you drive safely when you're driving. Also, the 500 is the max. So if you have three people and they're all suing for $250,000, your insurance is only going to pay 500,000. What does the 50 mean? That is property damage. So if you run into a house and the damage is less than 50,000, you're okay. If it's more than 50,000, guess what? It comes out of your pocket. All right, let's turn our attention now to a new section. I want you to open up a book to page 269, and I want you to copy everything that you see right there. Okay, so let's take a look here. First of all, you should know that 1 mile is 5,280 feet. Memorize that. Say it right now. 1 mile is 5,280 feet. I memorize it as 5,280. Okay. What does 55 miles per hour mean? Well, it means you're going to travel 55 miles in 1 hour. Make sure you know that. Okay? In any event, let's talk about reaction time, example 1. Research has shown that it takes 0.75 of a second to 1.5 seconds to go from the gas pedal, gas to brake. Some people instantly react. That's the quickest. Some people are a little more challenged and don't react as quick. That's the slowest. So the question is, how far will a car traveling 55 miles per hour travel in 81 seconds or 81 feet per second? Okay? So here's your proportion right here. Okay? So in 1 second, so 1 second, you will travel 81 feet at that speed there. Okay, so they're giving us that. So put given. All right, equals. Now, the reaction time. The reaction time is 0.75, so we're going to use that. That's seconds. So we're going to say 0.75 seconds over x. How far will they travel in that reaction time? That's the quickest. And then we're going to do the slowest. So we're going to say 1 second over 81 feet is equal to. The slowest was 1.5 seconds. So we're going to put that at the top. And x feet at the bottom. So copy that down. It's a proportion. And again, they gave us this. All right. So notice what I have. I have seconds over feet equals seconds over feet. That's the the quickest reaction time to go from the gas pedal to the brake. The slowest is right here. So I have the given ratio. I have seconds at the top, and I have seconds at the top. So make sure you do that correctly, okay? We're going to cross multiply. So we're going to get x times 1 is just x. So we're going to get 81 times 0.75. So we're going to take our calculator and multiply. So 81 times 1.75 is 60 feet. We're going to say approximately 61 feet. Okay? So imagine going 55 miles per hour and you're real quick. The quickest research has shown you're still going to travel 61 feet. Now, to give you an idea how far that is, this room, if we count these tiles, is maybe 25 feet, let's say. So you're going to go about 2.5 or 3 rows before you actually come to a complete stop. So keep that in mind. And that's why they tell you to keep 1 car length in back of the person in front for every 10 miles per hour. I'm pretty sure that's the standard. So you got to keep your distance, okay? And if you don't, you want to do that. We're going to cross multiply here. X times 1 is X. So we're going to get 81 times 1.5. This is the slowest reaction time. Some of you are real quick. Times 1.5. As soon as you see it, bam, you hit your brake. This guy is going to travel 121.5. Look at the difference. It's like twice. The quickest is half, and then the slowest is twice. At 55 miles per hour, you're going to travel that far. All right? Approximately. Let's go to the next one. Example 2, copy this down. Find the braking distance. The braking distance. All right, so you're traveling at about 50 miles per hour, 48. This is your braking distance formula. Okay, so you want to circle that and draw a line. That's the formula that they use when they investigate an accident, which could be a crime scene if you're under the influence. In any event, we're going to say the speed of the car is this, S. So we're going to say you're traveling 48 squared divided by 20. That's the formula, speed of the car. So we're going to take 48 times 48, press equals, divide by 20. That is 115.2 feet. Okay? So if you're traveling 48 miles per hour, all right, you're going to stop. The braking distance is 115. That would correspond, I think, to the slowest reaction time, but that's the one they use. Okay? You got to memorize that formula. Let's go to example 3. All right, so let's look at example 3. Copy all of that down. This is the total stopping distance. And here's another formula. So here's your braking distance that we just did, the speed of the car. This is how fast you're traveling, the speed of the car, S. So this person is traveling 48 miles per hour. They see an accident that's 200 feet away. Now, do they actually measure it? No, but they're just using this as a reference. And the question is, will they stop in time? Well, the formula is going to be how fast you're traveling, 48 miles per hour, plus the braking distance. So it's going to be 48 squared divided by 20. We already did that. That's 115 feet. So if you add this up, that's about 150. So it's about roughly about 165 feet, and the accident's 200 feet. So yes, they're going to brake in time. Okay? So today you have this problem right here. Copy this down, 1 through 8. And I think this is 4.8. Okay? If you get stuck, ask. The answers are in the back. Remember, copy the problem or paraphrase it. Show work. And then give me an answer. Some of you are just giving me the answer still, okay? I want the whole thing. All right, let's turn our attention to my last class. This is period 7. Now, the way you work this one is you isolate the radical. Well, the radical is already by itself. So now you're going to square both sides to get rid of that square root. So this cancels. So you get x plus 8. All right? And then this, you got to use FOIL. So you got to write that twice. I'm going to use the shortcut. I'm going to do it in my head. 2 times 2 is 4. 2 times x is 2x, and then times 2. Always times 2. So that's going to be plus 4x. And then x times x is x squared. All right? And now what you want to do is get it equal to 0. So you want to move the x over here, and you want to move the 8 over here. And I'm going to put this first. So I'm going to get x squared plus 3x minus 4. Does this factor? I think it does. 1 and 4. We want a plus in the bigger one. And I think that's it. So we're going to set each one of these equal to 0 and work it out. So when you do and move the 1, you're going to get x equals 1. And this one, you're going to get x equals negative 4. And you're done. Let's talk about today's work. Turn to page 131 and copy this down. All right, so how do you graph this? Well, here's 0, and here's 5. This bracket means it's included. So you want to color that in, and you want to go to negative 3. So this is negative 3, but it's not included, so you use an open circle. And that's how you do it. Sometimes they do it like this. They use that, and then they use that to include it. Okay, so when you check your answers, it's probably going to be like this, but you could do it either way. This one right here is going from 2, there's 0, there's 2, and it's included, to negative infinity. So this one is just going to go this way forever. There it is. And this is called negative infinity. All right? Copy down this one right here. Example 2, inequalities. Remember, you have your test this weekend. Draw your line. These are pretty easy. You're going to subtract 3x. You're going to move the 9 over and get 16. That changes to a plus. And divide by 2 and you get 8. There it is. You could plug it back in. If you did, this side is going to be bigger according to this inequality. Okay? Look, the open side is greater. So this side is bigger than that side, which is 1 dot. 1 dot, 2 dot. All right, let's go to the next one. Copy this next one down. What I would do for this next one right here is multiply everything by 2. You could change it to a decimal 1.5. But I'm going to multiply by 2. This is called clearing your denominator. 2's cancel there. Remember, if you multiply or divide by a negative number, you'd have to change the inequality. Put a star by that rule. We're multiplying by a positive 2, so we don't have to change it. Okay, so we get that. We're going to move this over. It becomes a positive 3x, so that's 5x. We're going to move this over. That becomes 10. So you're going to get x is less than or equal to 2. Less than or equal to 2. So that's how you read it. You read it from the variable. So it's 1 dot. So less than or equal to 2. So this is 2, and equal to would be that, and then less than would be negative infinity, and that's how you would graph it. Let's keep moving. We're almost there. Copy down example 4, then I'm going to give you your work. This one right here is a compound. It's 3 parts. So draw a line. Front, middle, back. You want to add 1 to all 3 parts. So plus 1, plus 1, plus 1. So that gives you a negative 2. When you add 1, you get 4. When you divide by 6, you get x's in between these two numbers. So this is 2/3 when you reduce. This one is 1/3 when you reduce. Excuse me. Okay, so to graph that one, here's 0, here's 1, here's negative 1. So 2/3, you're going to break this into 3 pieces. 1, 2, 3. So 2/3 is here, and it's less than or equal to. So you want to put it like this. It's equal to it. That's 2/3. 2 out of 3 pieces. Say that. 2 out of 3 pieces. This one is 1 out of 3 pieces, so break it into 3 pieces. So negative 1/3 is here, and it's equal to or bigger, so it looks like this. And that's how you would graph it. Today's work is right here. If you get stuck, ask. This is actually easier than what we did on radicals. All right, have a good morning.